It's so incredibly exciting to be here. I want to maybe first take a first second to just give another round of applause to everyone that put their hearts and minds and organized this conference. I do remember several years ago being at a different conference and talking with a bunch of other speakers saying that wouldn't it be absolutely fantastic to have a JavaScript conference in Dublin. Everyone would love to come over here. And it's incredible that Remo and team were actually able to accomplish this. And this is the second edition. I find that Dublin is one of the best cities for tech in Europe, and it's incredible that we have this amazing community here. So huge round of applause to the organizers. And another huge round of applause to all of you that are here and have created this space and time to actually come together, learn, and build this community together. It takes showing up, and it takes being present for learning and for building communities. So congratulations to you all. All right, and today I'm going to talk about accelerating Angular. And I will start by telling a story, which is about the American Air Force back in the 1950s. Pilots were having trouble controlling the aircrafts, and incidents were on the rise. And they couldn't understand why, what was going on. They looked at the skills, they looked at the tech, and nothing was really coming up until they looked at the cockpit. And what was interesting about the cockpit was that it was created for the average person. But who is really the average person? When they actually tried to answer this question by literally asking it, let's see how many people are fitting these average dimensions that we have envisioned for our cockpit. They started with 10 people. Surely there must be 10 people that are fitting the average dimensions. Turns out that there weren't 10 people. They went back to 5, and turns out that nobody actually fit the average person. And once they made this discovery, they redesigned the controls in the cockpit to be adjustable so that they meet the unique needs of their pilots. And that also laid the foundation of expanding the Air Force to women and building a more diverse and inclusive workforce. So how does that apply to JavaScript and web frameworks, you might ask? Well, each of us, developers, just like the pilots in those stories, we do have a different set of problems that we need to work through, a different set of tools that we love using or we have to use on a day-to-day basis, and a different set of customer needs that we have to solve for. So just as the Air Force made those controls adjustable and flexible, in the same way, we want to build into web frameworks and into the web knobs so that developers can use these tools in a way that fits their needs. My name is Simona Cotin. I'm an engineering manager on the Angular team at Google. And previous to that, I worked at Microsoft, where I helped make Azure Cloud better for web developers. And before that, I actually worked on building network data analytics using Angular and Java right here in Dublin. And this picture is from my very first Paddy's Day here in Dublin. I moved from Dublin, but it's an absolute joy to come back here and meet you all. So today we're going to talk a bit about innovation in the web ecosystem, and specifically how we're evolving Angular, and what does a principled approach look like from our perspective. But a lot of these principles actually apply to many other frameworks and how you should think about building frameworks. And basically, in Angular, we want to meet developers where they are and reduce the friction of building great user experiences on the web. And to do that, we prioritize making decisions that are rooted in evidence. We usually gather data through our annual developer survey. We triage GitHub issues, and every now and again, we root cause a lot of those GitHub issues. We do user research and general market research. And for major features, we also collect feedback through a request for comment process that we have on GitHub. And we also meet regularly with customers and with Angular Google developer experts. And if you're in the Angular community, you might know that we recently looked at evolving the control flow syntax. And in June, we published an RFC where we proposed a new syntax for a built-in control flow. And throughout that RFC, request for comment, we got a lot of feedback about the proposal itself, but a lot of opinions around the syntax itself as well, because as developers, we are very opinionated about the syntax, and that's the first interface that we have to work through. And something interesting happened. There was a proposal that came from the community itself that gained quite a bit of popularity. So the proposal that we had put there for the community was very close to the Svelte syntax or handlebars to implement the control flow, and the syntax that was proposed by the community was using the syntax, or what you might know as JavaScript decorators as well. So we saw that there was this huge interest in this alternative proposal, and we decided to close the RFC with the goal to do further investigation, kind of look at both syntaxes, look at the trade-offs, understand the developer experience from a readability, writability perspective. And we ended up adding a question to our annual developer survey, asking developers which one do you prefer. We did some user research in partnership with User Research International, and we interviewed 14 developers, half of them Angular, half of them non-Angular, and kind of talked through those aspects of readability, writability, and overall developer experience. And by nearly 2-to-1 margin across all of our polls and studies, both Angular and non-Angular developers prefer the community proposal for the syntax. If you're curious to read more about this process, my colleague Alex Rickabaugh actually posted a blog post yesterday, so this is extremely new and fresh. Please check it out on the Angular blog post, and we've basically decided to go ahead with the community proposal as part of the built-in control flow. And we're super excited about the outcome of this investigation and the collaboration with the community on this proposal. I mentioned quite a few times already our annual developer survey. For those of you that have already filled it out, thank you so much. For those of you that haven't and are using Angular on a day-to-day basis or on a regular basis, the survey is still open, so I highly encourage you to go to the website itself, the angular.io, and you'll find a link to the survey. We actually take this very seriously, and it feeds into our 6 months planning, yearly planning, and monthly planning as well. And just looking at the data here, we see that you love dependency injection in Angular. You are satisfied with the runtime performance that Angular brings, as well as the CLI tooling and keeping up with Angular releases. But we see that there's opportunities for improvement as well. So one that shows up here is the initial load performance time. And in the Cost of JS talk, Adi Osmani states that in 2023, the dominant cost of JavaScript is download and CPU execution time. User interaction can be delayed if the browser's main thread is busy executing JavaScript. So optimizing bottlenecks with script execution time and network can be quite impactful. If you haven't watched this talk, I highly, highly recommend you check it out. Adi and a few other folks are actually publishing on a regular basis content around the cost of JavaScript, and it's very insightful in how we can build applications with performance in mind. In Angular, we have thought about that quite a lot, especially given that that's come up in conversations and in feedback from customers as well. So we're working towards making it easier for developers to adopt best practices by default. And to improve download time and execution time, you can defer load entire parts of your application by configuring specific routes to be lazy loaded. And you can do that today with Angular very easily, and in fact, it's being used in production quite a bit. Basically, your application will be split into smaller chunks that will be lazily loaded when users navigate to that part of your application. But we wanted to go a step further, and we wanted to enable lazy loading for individual components. And that's actually achievable today using dynamic imports and ng component outlet. But the developer experience around that isn't great. It can be quite complex, and it's very error prone. So we wanted to build into the framework a primitive that's ergonomic, and it makes it easier for developers to actually adopt these performance best practices without a lot of friction. So this year, in June, we opened another request for comments, and we sent a proposal to implement what we call a deferred loading primitive, which allows you to do exactly that, to lazy load different parts of your view in order to have improved initial page load. So you can see an example of how that looks like, actually with the previous syntax, because again, very fresh decision. So here we have an Angular component and which has a template, and you can see that the first part, which is marked with defer, is lazy loading a calendar component and all of its dependencies. And then loading is the part that's always going to be shown, especially while things are loading. And then if there's an error while lazily loading or executing some of that JavaScript, we're going to show an error. Something to note here is that the API allows you to specify when this part of your template should be lazily loaded. In this case, it should be on when the component comes into viewport. And there's also the ability to define things like prefetching automatically so that the bundle is actually automatically prefetched so the user doesn't have to wait on that interaction. Another way to do more in terms of improving initial load performance is to actually move a lot of that work that is done on the client to the server. And this year we've invested in improvements to server-side rendering and static site generation. And again, going back to being evidence-driven, you can see that this is one of the areas for improvement that has been suggested in our developer survey as well. And we haven't done that in isolation either. We've worked with the Chrome Aurora team over the past few years to make sure that we built into Angular good defaults and primitives so that developers are able to build applications that have good core web vitals. And in particular, this year, we focused on working together on server-side rendering aspects of it. And the first project in this area of improving server-side rendering was actually enabling full application hydration. Multiple issues have been open on GitHub related to hydration, and one of the most prominent issues that has come up over and over again had to do with the flicker that occurs between the time when the page is actually rendered and when the page is ready for interaction by the users. And the flicker is due to the fact that Angular in the past was basically recreating the DOM. So after it has been rendered, in order to attach events and hydrate the application, Angular would just be recreating the entire DOM. And in order to address these issues, we have focused on implementing better hydration that has now shipped in May as part of V16. So if you're using server-side rendering with Angular, highly recommend that you enable full app hydration. To do that, you only need to add this provide client hydration while you're bootstrapping your application. It works both with standalone and module-based applications. And ultimately, our goal is to make server-side rendering and pre-rendering have first-class support in Angular. And some of you that have been using Angular for quite a while, you might be familiar with projects like Angular Universal, which have introduced server-side rendering and SSG into the Angular ecosystem quite early on. But we haven't really invested from the core team as much into some of these projects, so now we're bringing that as part of the core features. And as part of the work that we've done, we unified client-side rendering and server-side rendering dev server experience so that it's much faster and it doesn't require you to have different configurations. We've also added support for standalone and for ES build, and we've seen significant improvements from a dev server timing and build time perspective. Our customers are reporting 120% increase in web traffic when adopting Angular SSG, and 54% improvements in largest contentful paint scores when adopting full app hydration. And there's a lot more to come. Our roadmap is just increasing, and we're so excited to kind of spend time on this. Some things that are top of mind for us are things like partial hydration. We're also spending some time researching resumability, removing DOM emulation on the server, and looking into enabling things like streaming HTML. Another way to improve initial page load time that we invested in is introducing a primitive that actually enables images best practices. And part of that is enabling lazy loading of images that are not a priority image, and making sure that images that are above the fold, something like your header images, are actually the one that get prioritized. And there's a lot of primitives in the web platform that actually enable you to put together all of these best practices. But this space is moving very quickly, and they change all the time, and there's a lot of them, so it's hard to keep up with them. And as part of our overall goal of baking in good defaults and maybe higher level abstractions that enable developers to take advantage of these best practices, we decided to work on building a primitive that enables them. And part of the reasoning why we did that, we looked at things like data that is created by HTTP archive, and we see that 71 to 79% of the pages that had an LCP element, that was an image. So there's a lot of potential to improve core web vitals for all applications when we spend time optimizing these images. So I mentioned that intelligent lazy loading, so lazy loading all of the images that are below the fold, for example, so that we don't spend that initial time downloading those images. Prioritizing the critical images which are above the fold, as well as providing optimized configuration for a popular image tooling, which kind of enables folks to more easily use that tooling, together with built-in errors and messages and warnings. Those are part of the steps that we took to build this primitive. So in your applications today, you can use the new image directive by updating your image source to use ng-src. And for those of you that are not familiar with Angular, ng-src is what we call a directive, and it's basically a way to use a HTML attribute to attach behavior to a certain element. So when you apply ng-src, you are basically enabling all of the best practices that we have implemented within this particular directive. We also wrote some documentation about it, so check it out and start using whenever you get the chance. We've also looked at reactivity. This is a lot of the things that I've talked about are more at the higher level levels of abstractions, let's say, and they're building on top of existing primitives, whereas reactivity is more of a fundamental piece to a web framework. And over the past year and a bit, we spent significant amount of time root causing on GitHub and understanding like what are some of the fundamental areas that maybe need a bit of rewriting. As a reminder, Angular has basically existed on the web for more than 10 years with different iterations, but there's a lot that went into the framework, and it was a good time for us to kind of reflect and introspect on what can we improve in order to innovate on the framework. So we decided that reactivity is probably the best place where we can do great work. And our goals were to enable per-component change detection, zoneless Angular, and computed properties, and a few others. And currently, Angular relies on a library that's called Zone.js to drive reactivity. And the way it works is that it patches the browser APIs to listen to events that might lead to change detection. So this could be, events could be things like user interactions and data requests. And whenever any of those events are detected, Zone.js actually sends a notification to the framework and says, hey, something might have changed. And then Angular goes and runs the change detection algorithm, so does dirty checking to check, has any data actually changed? So you might already anticipate a few challenges with this approach. Some of them have to do with performance, others with increased complexity, and others with maintenance costs. So from a performance standpoint, Zone.js is quite inefficient because it needs to patch those browser APIs before anything happens in the application. So we have precious bytes that go into downloading Zone.js that need to be executed. And then not only that, but it just triggers much more than it should. It doesn't necessarily have granular control over what has changed in the application. It just says something might have changed. From a complexity perspective, the developer experience that Zone.js gives to Angular developers is that it's very simple to manage state. Like, you don't have any other abstraction on top of just using objects and JavaScript and mutating state anywhere. But the downside to that is that whenever we run into more complex issues like performance and having to debug, then things get a lot more complex and folks have to understand a bit what's happening underneath. So we're introducing Angular signals to drive reactivity for Angular. And it includes 3 different primitives: signal, computed, and effect. And you might have heard about signals from Solid.js. If you go way back, probably from Knockout. Recently, Svelte also announced runes. So there's a bit of a concentration in the web framework space in terms of how we drive reactivity for web frameworks using signals. And to explain a bit the 3 primitives, basically a signal is a way to notify that a value has changed, or signaling value changes. So we can look at this example where first name and last name are signals, and you initialize them by using the signal function and passing in a default value. And then we also have the computed primitive, which allows you to derive data from signals. So in this case, we can tell that full name depends on first name and last name, and we want to make sure that whenever any of the 2 signals actually changes, the full name is updated automatically as well. So you don't have to do any work around tracking those dependencies or actually updating the dependencies. And finally, we also introduce effect, so you can, whenever you want to run something in response to a signal change. And here we want to log to the console that last name has changed, and this will run automatically whenever last name changes. Okay, promise this is the last one. This is another area of improvement, and I'm excited to kind of share with you all some of the work that we've done in improving debugging and profiling in collaboration with the Chrome DevTools team as well. Basically, the goal here as we work together was to improve debugging and profiling for developers from an authoring perspective. A lot of times when we go to the debugging tools and we search for some of the code that we've authored, we have to parse through code that doesn't belong to us, that it's either framework code or comes from some node modules. And the work that we did in collaboration with Chrome DevTools team was to basically make sure that frameworks have a way to disable that for developers and kind of maintain that flow and focus by showing only the authored files. So the DevTools team have introduced an extension to source maps that's called Google Ignore List. And this extension is used to identify third-party code and to basically enable removing that from visibility from the quick open dialog, but also from the stack traces. So here you can see that our stack traces contain a lot of framework code. In the improved version, you're now only seeing the code that you've authored, as well as while debugging, you no longer have to step through framework source code. And this is available in all frameworks. So after we did this work, everyone was able to go update their framework to use this extension, and it should be in a browser near you available. So with all of these improvements, again, we want to meet developers where they are and reduce the friction of building great experiences on the web. And I want to leave you with this model that is actually created by Alex Komorowski. Highly recommend you check out his presentation on gardening platforms. This is going to be a whirlwind, quick summary, flash summary, but you're going to find a lot more useful information, especially if you're maintaining platforms. It's a very useful one. But basically, we start with the user needs at the top, and then platforms like Angular and many others are basically helpful in reducing the amount of bespoke code that developers need to write in order to accomplish user value. And we're building abstractions on top of the web platform in the case of Angular. And most of the times we actually want to take this approach to make it layered with good escape hatches and ways for devs to kind of reach deeper into the stack depending on what their needs are. Remember the extensibility and flexibility from the beginning. And actually we're never able to perfectly build all of the right abstractions at the same level, most of the times because we have like hard constraints and requirements are quite different. And actually, this is a more accurate picture where many times as we build platforms, we opportunistically build higher abstractions on top of maybe not so stable ground, but that is in order to meet some of those user needs. And this shows that like platforms and users and their ecosystem are constantly evolving, and these are some trade-offs that we might need to do. And initially we showed the user needs somewhere at the top there, but it's actually all over the place, right? Depending on who the user is, we might have a different set of needs. So platforms evolve alongside their ecosystem, and in an ideal world, they co-evolve together at a similar pace and in the same direction. We're excited about what's ahead for Angular, but most importantly, we're exploring all of these improvements and all of these changes that I've shared with you all with the priority of evolving Angular while also maintaining platform stability and bringing everyone along, kind of co-evolving with our ecosystem. And maintaining the properties of an opinionated framework that includes all of the knobs so that developers can use it in a way that exactly fits their needs. Thank you so much, everyone.